Capital Systems tools allow me to break complex products into individual component systems. Here, I'm using Capital Systems Modeler to develop a functional design where I have a physical sensor and I want to process its raw voltage output to convert it to a digital signal to be consumed by a software function. I then need to think about where these functions are going to be realized in my physical product. For this, I use Capital Systems Architect to develop my platform design. I associate my functional design to my platform design, and then I can assign the functions associated from my functional design to the components where they will run on my platform design. I know that I have information in the form of digitized sensor signals that are going to be consumed by some software in my flight control component, and I use carriers to transmit signal information between functions. Signals are automatically routed into the correct pathways. From here, we can use Insight to show metrics such as network bandwidth and CPU utilization to help guide the design process and determine which architecture is optimum. We can then push information out to PCB design tools such as Expedition and interconnect design tools such as Capital Logic Designer. I further develop my logical design in Capital Logic Designer. I can place devices and pins on the fly, or I can place them directly from my component library, and I connect the devices together using nets. Once my logical schematic is mature enough, I convert it into a wiring diagram by using the nets to wires function. I've assigned library parts to each of the line replacement units that I've used in my diagram. These library parts contain information about the harness footprint for those LRUs, allowing the harness connectors which plug into these LRUs to be generated automatically with just a few clicks. As with the systems domain, I also need to think about how these wires are bundled together into harnesses and routed through my product. For this, I use my topology abstraction in Capital Wiring Integrator. I associate the wiring diagrams with my topology plane, and I can take advantage of the fact that the two abstractions are now connected to cross-reference components across abstractions. Although my wiring diagrams are associated to my topology, I still have some wires that are unrouted. I can use the cross-referencing function again to see the physical source for these wires, and I can see that there are two possible routes for these wires through my topology, both through inline connectors which aren't yet present on my wiring diagram. To solve this, I use the Routing Assistant tool to select the route for these wires through the harnesses in my topology, following rules for signal separation. As this is a shared inline connector, I'm given the choice of which of the available cavities in this connector I want to use to route these wires through. As I prepare to produce my harness designs, I can use some of the automation tools within Capital to speed up manual processes, one of which is the back annotate tool. As the name suggests, this back annotates harness attributes and wire lengths from my topology to my wiring designs. In parallel, the 3D design for the harness is being developed using the electrical routing application in NX. Connectors and harness supports have been positioned in the model, and spline paths have been routed between them. The electrical component navigator in the harness model is currently empty, so the next step is to connect NX and Capital to bring in the electrical data. In Capital, I set a filter so I only export the wiring data for the rear cockpit harness, and I bridge out from Capital to NX. I auto-assign the connectors that are now in my electrical component navigator, and I can use cross-highlighting between NX and Capital along with the place splice command in NX to place the splices that have been brought in from Capital but aren't yet modelled in my harness. I now move to my electrical connection navigator in NX and auto-route the wires I've imported from Capital along the spline paths I've created. The lengths of each of the wires are calculated as they're routed along the spline paths. The wire lengths in Capital at the moment are the ones back annotated from my topology and so aren't very accurate. By bridging the routing data from NX back into Capital, I get the accurate wire lengths as modelled in NX, and I can process this information further in Capital, where I could perform volt drop analysis, for example. The final step is to create a harness drawing in Capital Harness Designer. I create a new harness drawing and I connect Capital Harness Designer to NX in order to bridge in a flattened version of the 3D harness model. Once the harness has been imported, I can go ahead and reposition the components on the harness drawing, and I can take advantage of more of the powerful automations built into Capital. Examples of which are matching the terminal part numbers to the connectors and wire gauges used, and generating a full bill of materials for all the raw materials required to build this harness.